Hello students, I am Ashish De. I am taking one of your subject, that is signal system. In my earlier video, I have discussed about discrete Fourier transform. In this video, I want to discuss about Laplace transformation. Now we know the formula of CTFT, that is continuous time Fourier transform of any function xt is represented by capital X of j omega, that is equal to integration over minus infinity to infinity xt into e to the power minus j omega t dt. Okay, so this is the Laplace transformation, Fourier transformation of any function xt, and inverse Fourier transformation x of t can be obtained from capital X of j omega by helping this formula, that is 1 by 2 pi integration over minus infinity to infinity capital X of j omega into e to the power j omega t dt. Okay, so these are the transformation pair, Fourier transformation pair of any function xt. We know that. Okay, now in this formula, if we replace j omega by sigma plus j omega, then we can get capital X of sigma plus j omega, that will be equal to integration over minus infinity to infinity xt into e to the power minus sigma plus j omega t dt. Okay, now and xt will be equal to 1 by 2 pi integration over minus infinity to infinity capital X sigma plus j omega into e to the power sigma plus j omega into t dt. Okay, so in this case, if we put sigma plus j omega equal to s, then from here we can see here sigma is a constant term. Okay, this constant is known as attenuation constant. Okay, and what is omega? Omega is the angular frequency. Okay, now the unit of attenuation constant is Nipah per meter, and unit of omega, that is angular frequency, is radian per second. Okay, so here omega is the variable, it consisting of frequency. Since frequency is a variable, so omega is a variable here, but this is a constant term. Okay, that is called attenuation constant sigma. Okay, now if we if we take derivative on both sides of this equation, we can get j into d omega will be equal to ds. Okay, so from here we can write that d omega will be equal to ds by j, right? So we can get it. Now if we apply this evaluation, then we can get the formula, that is xs. Here we are just putting sigma plus j omega equal to s, so xs equal to integration over minus infinity to infinity x of t into e to the power minus st dt. Here s equal to sigma plus j omega. Okay, now from here xt will be equal to 1 by 2 pi j. Why j? Because d omega equal to ds by j. Here is here, sorry, this is d omega, right? This is the d omega. See, since this is the inversion formula, so here will be obviously d omega, right? Now if we put d omega equal to ds by j, so it will be 1 by 2 pi j integration over minus infinity to infinity x of s into e to the power st ds, this. Okay, so this is the formula of Laplace transformation pair, right? this is the formula of Laplace transformation, and this is the inverse formula of Laplace transformation. Now this Laplace transformation is called bilateral Laplace transformation. Okay, so this is basically Laplace transformation of xt, of the function xt, right? So Laplace transformation of any function xt is represented by capital X of s, and the formula is integration over minus infinity to infinity xt into the e to the power minus st dt. Okay, now convergence of Laplace transformation. Now region of convergence for Laplace transformation. We know the formula of bilateral Laplace transformation, that is equal to xs equal to integration over minus infinity to infinity x of t into e to the power minus st dt. Okay, so this is the formula of Laplace transformation of any function xt. Okay, now s equal to sigma plus j omega, so this will be equal to integration over minus infinity to infinity xt into e to the power minus sigma plus j omega t into dt. Okay, so this will be equal to integration over minus infinity to infinity xt into e to the power minus sigma t into e to the power minus j omega t dt. Okay, so we can say here this is the Fourier transformation of the function xt into e to the power minus sigma t. Okay, so this is the Fourier transformation of xt into e to the power minus sigma t. Now from Dirichlet's condition, we can say that xs exist or this Fourier transformation exists if this function xt into e to the power minus sigma t will be absolutely integrable. Okay, so if it is absolutely integrable, then xs has the existence. Okay, that means to exist xs, minus integration over minus infinity to infinity mod of xt into e to the power minus sigma t dt should be less than infinity. Okay, so this is the condition when xs exists, xs has the existence. Okay, so now we have to find out the range of sigma for which xs exists, right? Start करो. Now see here, if xt is, if xt is suppose xt equal to e to the power 2t into ut. Okay, then we can see that this formula will be equal to from 0 to infinity e to the power 2 minus sigma into t dt. This should be less than infinity. Now this should be less than infinity when this portion 2 minus sigma, this should be less than 0. Okay, then only this portion less than infinity. Okay, now if this is less than 0, then we can get sigma greater than 2. So only when sigma greater than 2, then this function, this portion should the value of this integration will be less than infinity. Okay, now if this is positive, that means 2 minus sigma greater than 0, then from here we can see that sigma less than 2. Okay, so for the values sigma less than 2, the integration, this integration does not exist. okay, or this integration has the value of infinity because it is unbounded signal. Okay, for this, the graph of this signal will be this ever increasing. Okay, now in this case, so this is for sigma less than 2. Now for sigma sigma greater than 2, the graph of this function will be this. So this is sigma greater than 2, and this from this picture we can see that this is bounded signal. Okay, so it will be exist. Okay, so this integration will be exist when only sigma greater than 2, and when sigma less than 2, this integration has the value and it does not exist. Okay, that means the value of this integration will be nearly infinity. Okay, so from here we can conclude that the region of convergence, it depends on the value of sigma. It depends on the value of sigma, and also depends the value of xt, the nature of the function xt. Okay, so from this video what we learn, the basic formulas of Laplace transform and inverse Laplace transform. Okay, and relationship between Fourier transform and Laplace transform, and also region of convergence for the Laplace transformation.